Now that we have completed the definition of the mathematical model within ansys, let's get the solver to solve it for us numerically by generating the algebraic equations on the mesh that we gave it, and then solving those algebraic equations. Go into mechanical and click solve. And it says solving the mathematical model, and it's done the numerical solution. And let me save the project. It's hiding quite a bit from us, so let's think through, what happened under the hood. And for that, I'll go back to a slide from the big ideas and pre-analysis, and let me annotate my ansys model. The first step is to assign the temperature values for the nodes at which we have an essential boundary condition. So we have these nodes, so we have the corner nodes here, and then we also have the mid-side nodes. So it'll assign the temperature boundary condition for these 9 values. So they will be set, the temperature there will be set to 1 degree C. And you can see that, that boundary condition, the essential boundary condition, will be satisfied exactly. Then it needs to generate the algebraic equations at all the other nodes. So at an interior node like that, it'll, the algebraic equation will connect the nodes connected to all these elements. And then the right-hand side comes from the heat generation, but we haven't turned on heat generation here, so the right-hand side for those algebraic equations will be 0. And if you think about a node at the insulated boundary over here, now for that node, the right-hand side is going to come from the heat generation, which is 0, and then from the heat flux at the boundary. And in the 2D case, this is going to be a derivative in the normal direction, and again that's 0. So for these nodes, again, the right-hand side is 0. For nodes at the right boundary, such as this, the heat flux is not 0, so you're going to get a non-zero right-hand side for those nodes. So we have 121 nodes in total. 9 temperature values will be determined from the essential boundary condition. And then there are remaining 112, which are determined by inverting 112 by 112 matrix. And that's a sparse matrix because each temperature value is related only to its immediate neighbors. So this temperature value won't be related to all of these nodal temperatures. And it's inverted that matrix, and now we have all 121 temperature values. We'll do the step 3 later on when we go to check the energy balance. Now that we have all 121 temperature values, let's get ansys to do the post-processing for us.